look up at the night sky. It's a vast expanse that has fascinated humanity for millennia. It's a tapestry of twinkling stars, distant and mysterious, each one a beacon of light in the dark void. Each point of light represents a sun, often with its own family of planets, orbiting in a delicate cosmic dance. Have you ever wondered how these celestial wanderers, these planets, came to be? Their origins are as fascinating as the stars they orbit. Their story is a cosmic adventure, a tale of vast clouds of gas and dust, fiery births and the relentless pull of gravity, shaping them over eons. It's a story that began billions of years ago, with the very birth of our universe, a time when everything we know was condensed into a singular point. Our journey begins with a bang, the Big Bang, an event that set the stage for the creation of everything. Imagine a universe smaller than an atom filled with unimaginable energy, a cauldron of potential waiting to be unleashed. Then, in a fraction of a second, it exploded, expanding outward at an incredible speed, creating the fabric of space and time. This event, the Big Bang, marked the beginning of everything we know: space, time, matter, and the very laws of physics that govern our reality. As the universe expanded and cooled, energy began to transform into matter, a process that would eventually lead to the formation of galaxies, stars, and planets. The first elements to form were the simplest hydrogen and helium, the building blocks of the cosmos. These two elements, forged in the crucible of the Big Bang, became the building blocks for everything else in the cosmos, including the planets that grace our night sky, the stars that light up our universe, and the very air we breathe. The early universe was not a uniform sea of hydrogen and helium. It was a dynamic and ever-changing environment. Tiny variations in density, ripples in the fabric of space-time itself, meant that some regions were slightly denser than others. These minute differences set the stage for the formation of all cosmic structures. Gravity, that ever-present force, amplified these differences. It acted as a cosmic sculptor, shaping the universe. Over vast stretches of time, gravity drew in more and more hydrogen and helium atoms, pulling them together into enormous clouds. These clouds were the building blocks of future stars and planets. These clouds, vast stellar nurseries, are called nebulae. They are the cradles of star formation. Within these swirling clouds, gravity continued its relentless work. It was a slow but steady process. Denser regions within the nebulae pulled in surrounding gas and dust, causing these regions to collapse in on themselves. This collapse was the beginning of star formation. As more and more material fell inward, the temperature and pressure at the center of these collapsing clouds soared. The core became incredibly hot and dense. The heart of the cloud became a maelstrom of particles, a cosmic dance of unimaginable energy. This chaotic environment was ripe for the birth of a star. Finally, when the temperature and pressure reached a critical point, something incredible happened. A new star was born. Hydrogen atoms, forced together under unimaginable pressure, began to fuse, releasing a tremendous amount of energy. This fusion process is the same that powers our sun. This fusion reaction, the very process that powers our sun, marked the birth of a star. It was the beginning of a new cosmic journey. Don't forget to subscribe for more cosmic journeys and explorations. The birth of a star is not a solitary event. It is a grand cosmic dance that involves many players. The same cloud of gas and dust that collapses to form a star also gives rise to its planetary companions. This cloud, known as a nebula, is a vast and complex structure. As the central star ignites, bathing its surroundings in light and heat, the remaining material in the cloud continues to swirl around it. This light and heat play a crucial role in shaping the future solar system. This swirling cloud, flattened into a disk by its own rotation, is called a proto-planetary disk. It is within this disk that the seeds of planets are sown. The proto-planetary disk is a chaotic and dynamic environment. It is a place of constant motion and change where the forces of gravity, heat, and angular momentum interact in complex ways. Close to the newborn star, temperatures are scorching hot, reaching thousands of degrees. Meanwhile, further out in the cooler regions, a different process begins to unfold. Here, in the chilly outskirts of the disk, tiny particles of dust and ice, remnants of the original nebula, start to collide with each other. These collisions are the first steps in the long journey of planet formation. These collisions, initially gentle bumps, become more frequent and energetic as the particles are drawn together by their mutual gravitational attraction. Over time, these interactions lead to the formation of larger structures. Over time, these tiny particles, no bigger than grains of sand, begin to stick together, forming larger and larger clumps. These clumps are the building blocks of planets. This process, known as accretion, is the fundamental mechanism by which planets grow from the dust and gas of the proto-planetary disk. It is a slow but steady process that can take millions of years. As these clumps grow in size, their gravitational pull strengthens, attracting even more material and accelerating the process of accretion. Eventually, these clumps will become the planets, moons, and other bodies that make up a solar system. Join us on this incredible journey through the cosmos. Subscribe now and never miss an episode.